Am I audible clearly? Good morning. Am I audible?
Yes, sir.
Okay. So in today's lecture, we are going to start our new topic, that is nothing but a successive differentiation. Okay. Now that topic also involved a partial differentiation, how to solve the partial differentiation, Jacobian, and the application of that. That is very important topic as far as your engineering concern. Okay. So I have made a one PPT. I will share this PPT after this point is over. So what is the main objective of that particular differential calculus is that to prepare a student for various partial differential equations in engineering fields. So whenever you work with the engineering field, that time you will face a partial differential equation. How to tackle that partial differential equation? What is partial differential equation? So in this particular unit or module, we are going to discuss everything about the partial differential equations. So that partial differential equation, you will get it while solving boundary value problems, one-dimensional heat, one-dimensional wave equation, two-dimensional heat equation. So that kind of equations, whenever you try to solve, that time you will deal with the partial differential equations. Okay. So in that particular unit, we are going to see only basic things about the partial differentiation, how it graphically looks, what is exactly partial differentiation, what is the difference between total differentiation and partial differentiation, like that. Before going to that, we need to discuss also what is successive differentiation. Successive differentiation is nothing but what? Suppose we have particular function and we are going to find the derivative up to nth time, where n be any positive number. Suppose we have sin x. So what is the 100th derivative of sin x? Like that only. Like that we are going to see in that particular unit. So without, and these are the applications useful. These all are successive differentiation is useful to find the maximum point, minimum point, extension of the function, expansion of the function by using Taylor series, Maclaurin series, whether this is that particular curve is inflection point or tracing of curves. We have tracing of curves in the next in second year. So that is what we are going to see. So before going to start, whether my screen is visible?
No, sir.
No, sir.
No, sir. Okay. Just give me a minute. I will share the screen once again. Now it's visible?
Yes, sir.
Okay. So, here I'm going to share that PPT with you later on. So, see, suppose I have my y is equal to f of x. Any function that f of x be any continuous function whose derivative is exist. Then, if I define my y1, that y1 is nothing but my dy by dx. That you called as the first derivative, and sometimes you denote it by f dash of x. Yes or no? If I write down y2, my y2 is nothing but the second derivative, and I denote it by d2y by dx square, and that is nothing but f double dash of x, like that. Similarly, what will be my yn? Nth derivative. Okay. Not raised to n. So this is nothing but what I have my nth derivative, and you can denote it by f raised to n of x, like that only. Okay. Now, what we are going to see in that particular lecture, we are going to find a nth derivative of some standard functions. Okay. And let's take some first very simple function. My first function, let y is equal to e raised to ax. Can someone tell me what is my y1?
EAX.
A
into EAX.
e raised to ax. That is what? That is correct? Yes or no?
Yes, sir.
Yes, sir.
Okay, what is y2 then?
So a square into e raised to x.
A square into e raised to x, absolutely correct. What is y3?
So a cube into e raised to x.
So you will get some pattern here. So you can definitely tell me what is my y.
So a raised to n into e raised to x.
Correct. Everyone got this? Now you can substitute n is equal to 1, 2, 3, 4, 5, whatever it is. And you will get it out. This is my nth derivative. So this is the nth derivative of my first standard function. Got it, everyone?
Yes, sir.
Okay.
Yes, sir.
Now the second one. Let's take the second one. Suppose y is equal to some a raised to x, or you can take b also, no problem. A raised to bx. So tell me what is a raised to bx? Tell me what is a raised to bx? What is the nth derivative?
So will the first derivative be a raised to bx into log of a?
So you're on mute, you're not audible.
So sorry, students. Yes, please tell me. Yeah, what it is? Y is equal to a raised to bx. Anyone? The first derivative. What is y1?
So will it be a raised to bx into log of a?
Yeah, that's close to you. Closed. You are very close. It is a raised to bx into log of a. What happened with that b?
Sorry, so the b also has to be multiplied, right?
Why? Because
So
we are
it's
taking the derivative of b,
yes, sir.
and that is nothing but b came in the picture. Okay. What happened with y2? What
So
happened?
a raised to bx the whole square into b
No,
square.
you are talking about whole square. It is wrong. Anyone?
Log of a the whole square into b square into a raised to bx.
So that is correct. It's square and b square only. Why this is not square? Because I can write down this as y1 is equal to log of a into a, I just make a bracket, into b and into a raised to bx. Now while differentiation twice, this became constant term. Log a is the constant, b is the constant, I take it outside. So I need to just again differentiate a raised to bx. So what is in differentiation of a raised to bx? Is again this term. So what happened here? This term means what? A raised to log a into e raised to x. So e raised to bx you can take common out. E raised to log a into b, and log a into b, it becomes log a square into b square. Yes or no? Yes or no? While finding y2,
Yes.
this log a remains as it is, into b remains as it is, and just this one, what is the differentiation of a raised to bx? So it is a raised to bx into again log a, I make a bracket, into b, and you solve this, what you are getting? This.
So I have a
Yes.
question. How did
Yeah,
we
please.
get to the second derivative? I
Just
didn't understand that part.
differentiate one more time. So once you differentiate one more time, this is the constant term. I take it as it is. Log a into b. What is differentiation of 3x square? You just write down 3 outside, take a differentiate of x square, it's 2x, and it becomes 6x. Yes or no?
Yes, sir.
So that is what we did here. Whatever the constant term I have, that constant term I take it outside. So log a into b I take it outside because a and b are constant. Log a also constant. This is the constant term. I differentiate a raised to bx. What is differentiation of a raised to bx? Just right now you told me, no, this thing. So I put it as it is, and I'm getting this thing. Yes or no?
Yes, sir.
Got it, everyone?
Yes, sir.
Now, can someone tell me what is y3 without solving now? What is the pattern?
Log of a raised to cube into b cube into a raised to bx.
Log a, its cube, and its b cube. Very good. So what is yn then? What is yn?
A raised to bx log a to the raised to n, b raised to n.
Very good. B raised to n. Now, if you put, this is what I have my standard formula. Now we can put the cases. Okay. Case 1. What case 1? If b is equal to 1, then what happened? Then y becomes a raised to x. And then my yn becomes, tell me, if b is equal to what I will get? A raised to x into log a raised to a. Yes or no? Like that. Everyone got this?
Yes,
The
sir.
second important formula.
Yes, sir.
Can we go further? The next one.
1 minute, sir.
Yeah, please write down. Please write down. So this is what we are dealing with. Nth derivative of n different functions. Okay, and here you can use the special case. No one. Here you can substitute a is equal to 5, 6, 7, anything. You will get your simply nth derivative directly. So you need to remember this formula all the time. Okay, this formula, or what is the nth derivative of particular function. If you are done with this, then tell me. Done it?
Yes, sir.
Okay. So the next important and standard formula. So I'm going to solve one here, and I'm going to give you a same part as a homework. So let's take it. Third one, no? You can write down third. Y is equal to sum ax plus b raised to n. We have some certain condition on m. Here m is positive, belongs to z plus positive here, and okay. Firstly, we just consider this one only. Firstly, we will consider this one only. Once we get the formula, then we put again some conditions. Okay. So here positive integer means what? It is 1, 2, 3, 4, 5, 6, 7, like that up to 1000 crore, whatever. So tell me, what is my y1? Y1?
So will it be m into ax plus b, and that will be to the power of m minus 1 into dy by dx of ax plus b?
That is nothing but a. What is
Yes.
derivative of ax plus b is a. That
A.
m comes here forward. So m into ax plus b raised to m minus 1. Absolutely correct. Tell me, what is my y2? M
So that will
as it
be m
is.
square minus 1.
No. How it is m square?
No, so I
Don't-
multiplied that part.
No need to multiply. Once you multiply, you will get a very confused statement. We want a
So
very straightforward. M into m minus 1 into
ax plus b
what
raised
is
to the
a?
power
What is a to the power
Square.
2? Ax plus b raised to what is the power?
m minus 2.
M minus 2. Got it, everyone? Simply, here a is constant, m is constant. I take an outside. I just differentiate this term so that m minus 1 can here, and here m minus 2 can. And the derivative of ax plus b again a, that initial a, and the whatever the derivative a we are getting, that is a square. You can write down y3 also. Now tell me, what is y3?
Sir, m into m minus 1 the whole square. into
No,
a cube.
why whole square? I'm not getting. Why it is you are
So
getting?
m minus 1 we have again. No, so sorry, that will be into m minus 2. Sorry.
M minus 2. Correct.
And
Into
a cube
a cube into
ax plus b to the
raised
power
to
of m plus 3.
m minus 3.
M minus 3. Sorry, sir.
Okay. So this is what you are getting. Now tell me, if I go like that only, what will be my yn end derivative?
So m into m minus 1 up to m minus n into a
Up to
raised to
what? Up
n
to what?
m minus n.
M minus n. Okay. Okay. Any other one who wants to modify this statement, or can I? This is the correct one.
M
Any-
minus n minus 1.
M minus n minus 1 you are talking about. So I just make a bracket. Huh? Why? You are absolutely correct. Can you tell me why it is? M
For
minus-
3 it is m
Ah.
minus 2. For 2 it is m minus 1.
See here, what you need to observe here, whenever I take the second derivative, I have m minus 1 up to minus 1, we have factors. When we have 3 variables, we have up to 2 factorials. So when we have n variable, we should have n minus 1 factors. Okay, what is next? A raised to,
A raised to n
very good,
into a raised into ax plus b whole raised to m minus n.
m minus n. Exactly. Okay, everyone understand that statement? How we stopped here? Now we just solve this further. Huh? We just solve this further. So what I'm getting, m into m minus 1, here m minus 2 dot dot dot. I just gave that minus sign inside, so m minus n plus 1. Okay, so more simplicity purpose, I just multiply here m minus n, and here also m minus n. The equation remains same because this get cancelled. We have everything in the multiple side. So next we have m minus n minus 1. So I just write down here m minus n minus 1. Okay, so dot 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 dot. Here m is positive integer, n is also positive integer. So if I subtract 1 1 1 1, lastly I will get 1. So dot 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 1. So whatever I have written, this extra part, I just divide that extra part in the denominator. What I have remained, a raised to n into ax plus b raised to m minus n. So I write down this as m minus 1 and into 1. So I am getting m factorial. Okay. Next, a raised to n into ax plus b raised to m minus n divided by m minus n factorial. And here we assume that my value of m is greater than n, like that. So anyone tell me whether any doubts you have here? Any doubts, anyone?
So can you just repeat the end formula that you got once, please?
What I did, see, we have here m minus 1 up to here, you don't have any problem. I just give the minus sign inside, I will get that. Now I wanted to make this formula is very clean and clear. So what I did, I again multiply by some number and divide by some number. So what the term I should multiply? I multiply by this one, m minus n minus 1 dot 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 1, and I divide the same thing below. So what is factorial formula? So here I am saying m is greater than. So that's why when m is greater than n, it means m minus n is also greater than. So this implies m minus n is also greater than 0. So if this term is greater than 0, it means what? If I subtract from m to any n, what is n? It is first derivative, second derivative, third derivative, fifth. We cannot take no 3 by 4th derivative or 1 by 2th derivative. We are taking what? All the whole numbers derivative, 1 2 3 4 5. So if I subtract from any positive integer, the any small positive integer, and if I keep going subtracting minus 1 minus 1 minus 1, what the last term I should get? 1 only. Yes or no? You have your 10 numbers. Suppose m is nothing but 10, n is nothing but 5. So 10 minus 5, 10 minus 6, 10 minus 7, 10 minus 8, 10 minus 9. Lastly, you will get 1, no? So that extra term I have multiply and I have divide. So what I will get after doing this thing? So I have m factorial. What is m factorial? M into m minus 1, m minus 2, m minus 3, m minus 4, dot 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 up to 1. That is nothing but my m factorial. A raised to n as it is, ax plus b raised to m minus n as it is. What is denominator? So m minus n, m minus n minus 1, m minus n, n minus 2, like that, up to what? Up to 1. That is nothing but m minus n factorial. Yes or no? Yes or no?
Yes, sir.
Yes.
So this is what you are getting your in a new way. This is nothing but my nth derivative of a function when m is greater than n. Okay, got it, everyone?
So we can keep it as it is, no?
No
Like
problem. While
as
solving the example, but see, we have lots of example. While solving the example, we are going to use this formula because this is what the standard formula we have. Because here we have cases also. What are the cases? So case number 1. If m is equal to n, what happens? So what happened? Y, what I am getting? Y, ax plus b raised to n. Tell me, what is my y n? If m and n have the same value.
Denominator with generator 0.
Denominator 0, how it is 0?
no, it is 1. Denominator is 1
Yeah,
because 0 factorial is 1.
absolutely correct. What happened with the numerator?
So it will be n factorial into a raised to n.
M
Um,
factorial, or you can write down m is equal to n, you can write down n factorial, no problem. So it is n factorial into
a raised to n.
a raised to n, that's it. Can someone tell me what is n plus 1? Its next derivative?
0.
Absolutely correct. It becomes 0. Why? Because here you are getting constant term. The next derivative is 0. Everyone got this? Now what happened? Please tell me, if my value of m is less than n, then what happened? What is my ym? If my value of m is less than n, or greater than, we have a formula, or equal, we have a formula, but what happens if we have less than? Yes, tell me. Anyone? Yes, think in a different way, you will get it. It's not that much of hard. Whether we need to do the sum calculation.
Instead of m minus n factorial, it will be n minus m factorial.
The answer is 0. Why 0? Suppose let's take a particular example. I have ax plus b raised to 3. Okay, and what I am saying, m value is less than n. It means n is greater than. So I need to find my y4, y5, and y6, whatever. Okay, so we need to find out that. So what is my y1 here for this particular problem? It is 3 into a into ax plus b raised to 2. Yes or no? What is my y2? Y2 is, am I audible?
So
Yes.
6a square into ax plus b. Yeah.
What is y3?
Um,
6a cube.
6a cube.
That is what we have up to this. But what they are saying, if my value of n is greater than m, my m is here 3, and if m, whatever I have, is less than n. So n value is greater. What is my y4 came here? Just like now someone is saying it's 0. How you calculate 0? Because it's 0.
Yes, sir. 0.
What is y5? 0. What is y6? 0. Whatever next terms, all the terms, what you will get? As 0, 0, 0 only. Yes or no?
Yes, sir.
Yes, sir.
So this is what you have. This is what you have. Got it, everyone? Clean and clear?
Yes, sir.
Anyone, any doubts here? Can I give one example as a homework?
Yes, sir.
Okay. So this is what you have. This is what you have for the standard formula y is equal to ax plus b raised to n. Now I'm going to give you one formula. You need to work on that and just tell me what it will become. It is a homework for you. Okay. And tomorrow we will discuss on that formula because I want a calculation from your side. If y is equal to 1 upon ax plus b raised to m, and here I am considering m is positive. Okay, now you just calculate this one, which is work on the same way, but I'm not going to repeat the same calculation. You just did for a homework. You just do it for a homework and then tell me. Okay, can you do it? It's simple.
Yes, sir.
Okay, just try to do that. Okay, so I'm going to start with my next point. This is, I think this is the fourth one. Then if this is my third one, this is the fourth one. So now fifth one. Y is equal to log of ax plus b. So let's find out what is y1.
So A upon AX plus B.
Very good. A upon ax plus b. Simply log x is nothing but 1 upon x and derivative of ax plus b is nothing but a. So a upon ax plus b. What is y2?
So minus A square upon AX plus B whole square.
Minus a square upon ax plus b whole square. What is y3? So you can write down this for your simplification. Ax plus b raised to minus 2. So you will right now recognize what you will get. Y3. So I think you will get y3 a cube into 2 into ax plus b raised to minus 3. Am I correct?
Yes, sir.
You will get your y4. Can someone tell me what is y4? Minus a raised to 4, 2 into 3 into ax plus b raised to minus 4. Yes or no?
Yes, sir.
Yes, sir.
What is y5? Now tell me what is y5?
So A raised to 5
Hmm.
into 2 into 3 into 4
Very good.
into AX plus B whole raised to minus 5.
Yes. Now, what is yn? Think on that. What is yn?
Plus minus a raised to the power
What is
n.
plus minus now? When we have to take plus, when we have to take minus. What I want a standard formula. If I substitute the value of n, see in the above expression here, suppose in that particular example, suppose I have y is equal to 4x plus 9 raised to suppose 5. So what is my y3? So how you can find out here. Here you can substitute. Your n is equal to 3, m is equal to what is my m? M is equal to 5. You can directly substitute in that formula y3 is equal to m factorial. M is nothing but, so directly 5 factorial a. What is value of a? A is nothing but 4. So 4 raised to n. So 4 3 into that term as it is 4x plus 9 into m minus n. So m is 5, n is 3. So m minus 3 is 2 whole divided by m minus n factorial. So 5 minus 3, that is nothing but the 2 factorial. Directly answer once I substitute the values. So once you're saying plus or minus, so when we have to take plus, when we have to take minus, that is also
So
important.
it should be -1 raised to the power n minus 1.
Very good, very good. -1 to the power raised n minus 1. Okay, next.
So a to the power n.
Okay, a to the power n, no problem. Next.
So 2, 3, 4, up
Okay,
to
we write
n
down.
minus.
We write down firstly 2. Then firstly we write down that. Then we will solve. If someone wants to add something, you can. 2, 3, 4, up to what?
N minus 1.
N minus 1. Okay, good. What is next? Or I just divide everything by ax plus b raised to what is power?
N.
N. So what is that? 2 into 3 into 4 into n minus 1? Can I write down that as a n minus 1 factorial?
Yes, sir.
What is n minus 1 factorial? It is n minus 1, n minus 2, n minus 3, dot, dot, dot. Last term is what? 4, 3, 2, 1. That's it. Minus 1, minus 1. What is the before that term? What is the term you are getting before that? N minus 2, no? Here, before n minus 1, what I have? Before 4, what I have? 3. I just need to subtract 1. So if I subtract 1 here, n minus 2, n minus 3, n minus 4, n minus 5, like that, no? Are you getting? Why n minus 1
Yes, sir.
factorial
Yeah.
getting?
Yes, sir.
Yes, sir.
So this is what you have a formula. Okay. But if n is equal to 1, this formula will work. N is equal to 1. Yeah, it will work. See,
Yes.
this is you are getting y1. So for n is equal to 1, you are getting. That's it. So we are done. Why? Why? Because here we are getting something, here we are getting something. That's why you need to check it out whether it is work for all the formula or not. So I might confuse that whether it is will work for one or not, but it will work. So this is what your formula you have. Okay. Clean and clear, everyone. Write down this formula for logics. Can we go for the next one?
1 minute, sir.
Yeah, please write down. Done it? Done it?
Yes, sir.
Okay. So next sixth one, y is equal to sine ax plus b. Before going to that, can someone tell me what is sine theta plus pi by 2? Sine theta plus pi by 2.
The cos
Cos
theta.
theta.
Cos theta. Very good. And what is cos theta plus pi by 2?
Minus sin theta.
Minus sin theta. Very good. So we are going to use that terms here while solving this. Okay. So tell me, what is y1?
So a
So-
cos
Cos A cos AX plus B.
Ax plus b. Very good. So instead of writing cos, I just write down this. A is nothing but sine ax plus b plus pi divided by 2. Is it okay for you? Because sine theta, that ax plus b is nothing but theta. So sine theta plus pi by 2 is nothing but cos theta. So can I, this is, you are getting, this is nothing but my y1. Okay. Everyone agree on that?
Yes. Sir. Yes. Sir.
yes, sir.
So if I try to find my y2, so what is y2 then? A square. Firstly, I write down in a simple manner cos of ax plus b plus pi divided by 2. Is it okay? Is it okay?
Yes, sir.
Because b plus pi by 2 is the constant and derivative of that term becomes 0. Just that a, and I have multiplied by that. So can I again write down that a square is nothing but sine of ax plus b plus pi by 2, again pi by 2. So what I will get? A square sine of ax plus b plus 2 into pi divided by 2. Everyone agrees on that statement?
Yes, sir.
Okay. So can someone tell me what is y3 now without solving? Y3.
A square sine AX plus B plus 3 pi by 2.
Very good. Now what is a yn then?
AN sine AX plus B plus N pi by 2.
N pi divided by 2. Correct. Got it, everyone? How simple is this?
Yes. Sir.
Yes.
Okay, so you can put n is equal to 1, 2, 3, 4, 5. Just a to the power, and that sine n pi by 2 will add. Okay, that is very simple. Now can you do it for the cos? I just erase that one. Do it here simultaneously for the cos one and tell me what it will come. So 7 y is equal to cos of ax plus b. Tell me what will be my y1?
So minus a sine
Minus a sine
ax plus b.
ax plus b. So how I can write down my y1?
So cos of ax plus b plus pi by 2 in
So
place of
a as
7.
it is. Instead
Yeah.
of sine, I can write down directly cos. Cos, and what I will get? Ax plus b plus pi by 2. What happened with that minus sign?
So it gets adjusted because cos.
Cos of cos theta plus pi by 2 is nothing but minus sign, and that minus minus will adjust it. So tell me now directly, what is yn then?
A raised to n cos ax plus b plus n pi by 2.
Ax plus b plus n pi divided by 2. Absolutely correct. Write down. If you have any doubts, please clear your doubts, huh? Because it's very simple. Just you need to lots of things we are going to deal with here, lots of things. Okay, so trigonometric one and simple adjustments. So if you have any doubts, you can clear your doubts here only. Okay, because later on, if somehow, suppose while solving the problem, if you forgot the problem, You need to find out, because within 1 minute you can easily find what is nth derivative of cos ax plus b, sin ax plus b, or log x, or something like that. Okay. If you're done with that, then tell me. Then we will go further. Done? Understood?
Yes, sir.
It's very easy. Huh? It's not that much of hard. That is what I think. Now the hard will come. So these are the some 7 and 8 are the very basic and very important as far as your Leibniz theorem, whatever the next point we have, it concerned. Because there only, if I have to find the nth derivative of sine, I'm going to directly put this. I'm not going to see this middle step. Directly nth derivative is a raised to n sine ax plus b plus n pi by 2. Like that only we are going to do. Okay. Everyone done with that?
Yes, sir.
Can I go further? Yes or no?
Yes, sir.
Okay. So write down the next one. Yeah. The next one is nothing but eighth one. You can say that y is equal to e raised to x into sine bx plus c. E raised to x into sine bx plus c. Before going to that, can someone tell me what is the formula for sine a plus b?
So sin A cos B plus cos A sin B.
Sine a cos b. We have sine, so plus as it is. Here you can write down cos a into sine b. Okay. So we are going to solve. We are going to deal this bit. So first find out y1. So what is my y1? Y1 is nothing but
So AB e raised to ax cos of bx plus c.
AB. How AB come?
So product rule will apply.
Exactly, product rule. So differentiation of u dot v is nothing but first u1 u as it is differentiation of v plus v as it is differentiation of u. Something like that, no?
Yes, sir.
So first I differentiate this. So a into e raised to x as it is. Differentiation of e raised to x, then sine as it is. So sine bx plus c as it is. Then we have plus. Then second term as it is, first term as it is, e raised to x as it is, and differentiation of sine. What is differentiation of sine? Cos bx plus c. So first I differentiate first term, second term as it is, then first term as it is, differentiation of c. Okay. So here that particular proof contain, we are going to substitute something because I want this in terms of sine, no? So I just put my a is equal to the whatever that constant. I just find out a is equal to r cos theta. So here theta is nothing but my new variable, and b is equal to r sin theta. Why I'm going to substitute this? Because I want this formula in very simple manner. That's why I'm substituting this. Okay. So this, if I solve, if I find a square plus b square, and if I take a square root, so I will get this as a r. Check it out. And theta is nothing but what? Tan inverse of theta. Sine upon cos is nothing but tan. So b divided by. Yes or no? If I substitute this, this implies I am getting the value of r is nothing but this, and value of theta is nothing but this. Okay. So I substitute this value in the above one. So for y1, what I am getting, e raised to x, I can take it outside. The value of a is nothing but what? R cos theta. So r cos theta into sine bx plus c plus what will come here? E raised to x already taken outside. What is the value of b? R sin theta. So r sin theta into cos bx plus c. So which formula will work here? Can someone tell me? I can take r also outside, e raised to ax also outside. So what I should write down for
So
this?
sine theta plus bx plus c.
Sine bx plus c plus theta, can I write down? So this is nothing but what I have my y. But here you have substitute something. So where a is nothing but the value of a is nothing but r cos theta and b is nothing but r sin theta. That is what we have substitute. Yes or no? So similarly, I will get my y2 that you need to do as a homework. How I am getting this one? Bx plus c plus 2 theta. Can someone tell me how I am getting 2 theta here? Similar way, whatever we have done it above, same do it here. Okay. And finally you will get yn is nothing but r. Oh, here 2 is here, so r square. Sorry. R is here, so r raised to n. E raised to x as it is sine bx plus c plus n theta. That is nothing but the nth derivative of given function. Check it out, everyone. Anyone, any doubts? Clear your
So can you
doubts.
scroll up a bit, please?
Yeah. I will. So check it out. So don't consider, don't remember this proof. Just remember y1, y2, y3. Okay. And these are the substitutions. These are the important ones. Everyone understand this?
Yes, sir.
Okay. Now similarly you have this for the cos 1 also. So just think this for the cos 1 and we stopped here. So this is the 10th one or 9th one. Just check it out. Y is equal to e raised to x into cos bx plus c.
Sir,
Yes.
Anshul Rathi is in the waiting room.
Anshul 5 minutes पहले join. Okay, no problem. So yn, you need to check it out. This is as a homework. R raised to n e raised to x into cos of bx plus c plus n theta. That is what you will get for the cos 1. Similarly for the sin 1, just the formula of sin a cos b remains, where r is equal to a cos theta. Oh, sorry, a is equal to r cos theta. A is equal to r cos theta and b is equal to r sin theta. These are the substitution we do. Okay, these are the basics one. These are the basics ones. What we are deal with today's lecture. These are the basics ones. Okay. Okay. So that's it for the today's lecture. Anyone, any doubts?
No, sir.